here, find the value of the derivative at the relative extrema. And so to do that, we just take the first derivative. So f prime of x is equal to the derivative of the numerator, which is 2x times our denominator, x squared plus 4 minus the numerator times the derivative of our denominator, which is 2x as well, all over our denominator squared. And so here, f prime of x is equal to hopefully you don't see that. An email from my wife. Anyway, 2x to the third plus 8x minus 2x to the third all over x squared plus 4 to be squared. And that gives us 8x all over x squared plus 4 to be squared. Then it says calculate this derivative at the point. So f prime here of 0, right? X is 0. So this is equal to 8 times 0 all over 4 squared, 16, 0. Now for this next one, you want to find that derivative. We're going to write this as x plus 4 times x to the negative 2. So g prime of x is equal to 1 minus 8 times x to the negative 3. We simplify that, so this is 1 minus 8 over x cubed, and you can write this as x cubed minus 8 all over x to the third. Here, evaluate the derivative at x equal to 2. So g prime of 2 is equal to 2 to the third minus 8 all over 2 to the third. That's 8 minus 8 over 8. You get 0 divided by 8 is 0. They're begging the question that at the extrema, the first derivative is supposed to be either 0 or it's not differentiable. Let's look at this next one. F prime of x is equal to 2/3 times x plus 2 to the 2/3 minus 1. That's negative 1/3 times the derivative of the inside, which is just 1. F prime of x is equal to 2 all over 3 times x plus 2 to the 1/3. Here we evaluate this at x equal to negative 2. There's a spike there, so if it's a spike, then that begs the question that the function does not have a derivative there. Let's see. F prime of negative 2 is 2 over, this is negative 2 plus 2, you get 0, right? So, you know, it's 3 times the cube root of 0. Does not exist. So here, let's note functions that functions are not differentiable at values of x where the graph has a spike, sharp turn, or a jump. Functions are not differentiable at values of x where the graph has a spike, sharp turn, or a jump. Okay. Here for exercise 11 to 16, find the critical numbers of the function. So we just take the derivative and set it equal to 0 and solve for x. So f prime of x, cannot see the prime, is equal to 3x squared minus 6x. Now we set f prime of x equal to 0. That implies that this term here, I'm going to factor out at 3x, is set to equal to 0. That implies that x equal to 0 and x equal to 2. We find the derivative of g. So g prime of t, we use the product rule. The derivative of t is 1 times the second, the square root of 4 minus t, plus the first times the derivative of the second, which is 1/2, times 4 minus t to the 1/2 minus 1 is negative 1/2 times the derivative of the inside, which is negative 1, all over our denominator. This is, excuse me, this is not the quotient rule. Okay. So it's the product rule. So it's the derivative of the first times the second plus the first times the derivative of the second. We'd simplify that. G prime of t is equal to the square root of 4 minus t. This is minus t all over 2 times the square root of 4 minus t. Now we set g prime of t equal to 0. This implies then that we have this square root of 4 minus t over 2 times the square root of 4 minus t is set to equal to 0. So we're going to combine these two terms here. The denominator is 2 times the square root of 4 minus t. So we multiply to this fraction 2 times the square root of 4 minus t divided by 2 times the square root of 4 minus t. So we have 2 times the square root of 4 minus t all over 2 times the square root of 4 minus t times the square root of 4 minus t minus t all over 2 times the square root of 4 minus t. That's set to equal to 0. So this gives us 2 times the expression 4 minus t all over 2 times the square root of 4 minus t. Simplify that. That gives us 8 minus, this is 2t minus 2t minus t, so that's minus 3t. It's all over 2 times the square root of 4 minus t. You set that equal to 0, multiply both sides by the denominator, and that implies that we end up with 8 minus 3t is equal to 0. That implies that t is equal to 8 divided by 3, and this t is less than 3. So, oh, I want to try something out. See if this works. See it. Try that. Well, here in exercise 1736, find the absolute extrema of the function on the closed interval. The instructions say you can find the critical value, evaluate the critical value, and then evaluate here the endpoints. What I do is I try to graph it, and then from the graph to try to be able to determine the so-called absolute maximum or the absolute minimum. So for this function, so here if we let x equal to -1, so that gives us 3 plus 1, we get 4. And if x is 2, then we have 3 minus 2, that gives us 1. So if we plot those 2 points, we get x is -1, y is 4. Let's see, it's there. Then x is 2, y is 1. Let's say somewhere around there. Okay. But this so-called line only goes from when x is from -1 to 2. So it only goes from here to there. So we don't need those parts, right? And so if that be the case, then this value here is the absolute minimum. And that's the point 2, 1. And this value here is the highest that it goes because it's a closed interval. And there they gave us -1. It's the highest one. So -1 to 4. It's an absolute maximum. Let's take the next one. Well, they tell us you can examine the first derivative. So this gives us 4x minus 8. You set this equal to 0. And that gives us x is equal to 2. can't do a y with that one. So when x is 0, here we get 0. And when x is equal to 2, right, we have g of 2 is equal to 2 times 4 minus 8 times 2. So it gives us 8 minus 16. So here we get a negative 8. And then when x is equal to 6, we get g of 6. It's 2 times 36 minus 8 times 6. So that gives us 72 minus 48. So we get 24. So the smallest value is this 2 comma negative 8. So this is our absolute minimum. And this is the biggest value, 24. So this is our absolute maximum. And if you look at the graph of that, notice here for this problem, if we look at the x-intercepts, if we set the function equal to 0, we get 2x squared minus 8x equal to 0. Gives us 2x if you factor that out, times x minus 4 equal to 0. This implies that x equal to 0 and x equal to 4 are our x-intercepts. So we have a minimum at 2 comma negative 8, and then we have x-intercepts at 0 and 4. That's not something like that. This graph seems to be a little bit more narrow, but the graph is not drawn to scale, correct? So here we have x-intercept there, and then it's supposed to be 4 comma 0. It's too fat, it's too wide. The minimum value is here. Two comma negative 8. Then the maximum is way up here, like x equal to 6, y is 24, which is like way up there, but this guy's not drawn to scale, but you get the idea. Just note that the graph It's not drawn to scale. Okay, so here for the next problem. Now you recall this guy from algebra, that t squared plus 3 is never equal to 0. So here we have since t squared plus 3 so we have no vertical asymptote. Look at the degree in the numerator and your degree in your denominator. They're the same. So that means that if you divide by the leading coefficients, we get 1 divided by 1. That's our horizontal asymptote. Y equal to 1. This graph is always positive, t squared plus 3. What happens at t equal to 0? G of 0 is equal to 0 divided by 3. So we get 0. Now the graph of that that's the x-axis. The line y equal to 1 is an asymptote. So the graph, if it's an asymptote and is always positive, again, this is the x-axis, the y-axis. That means that the graph is above the x-axis. Is it up here? No, it's not. Why? Because I have a point at 0, 0. So it's riding with the asymptotes. It drops down there. Then it rides back along with the isotope. So the minimum you can see is at the origin, and then the absolute maximum will be at these endpoints, t equal to -1, t equal to 1. So we know that we already get 0, 0. What happens at -1? Well, that's 1 over 1 plus 3. We get 1/4. And then the same thing here when t is equal to 1, we get 1/4. So here we have absolute minimum. And since we get the same value, we get absolute max at these two values. So the minimum is here, and then for x equal -1, you get like a 1/4. You know, this graph is only going so far. Let's see, it's there and here. Again, not drawn to scale. You don't need any of this stuff, right? So the graph is only here. I guess that'll be good for this part there. Right? You recall from algebra that this is a rational function. Oh, I forgot my help. We have a vertical isotope at s equal to 2. Now the graph does this, and since we're on the interval from 0 to 1, you know, the graph typically does this, then it does that, right? But you only want to examine from s goes from 0 to 1. So from here to there. Well, at those endpoints, you're going to have your maximum and you have your minimum. So when s is 0, we get 1 over -2, which is -1/2. Then when s is 1, we get 1 over -1, or just -1. So here we have the absolute maximum, and this gave us our absolute minimum. Now the graph of this, it has the basic shape of the absolute value graph. So this says to go up 3 and to go over to the right 3. So we go up 3, and this tells us, you know, t minus 3 equal to 0. T is equal to plus 3, so that means to go to the right 3. And at that point, that's the here negative in front, so that's going to be the maximum. So we're going to go up 3, 1, 2, 3, and then go over to the right 3, 1, 2, 3. So we're there. Okay. So this point here is 3 comma, this is 3 for y, and that was 3 for x. It's 3 comma 3. So this is our maximum. And the minimum values, well, we have to investigate at t equal to -1 and t equal to 5. So here at -1, so that gives us -1 minus 3 is -4. We get +4, so 3 minus 4 is -1. So here when t is -1, we drop down here. And then what about when t is equal to 5? So we get 3 minus here. 5 minus 3 is 2, so 3 minus that 2 gives us a 1. So 5 and 1, somewhat there. So the maximum value, oh, don't forget about the 3 comma 3, right? So the maximum value is this guy, so this is the absolute max at the 3 comma 3. And the smallest value is a closed interval. You can do that. The smallest value is this guy, so this is the absolute minimum. Okay. Thank you.